Let's look at fever now. We're still in level 2 of the innate immune response. Normal body temperature is between 36 to 38 degrees Celsius or 97 to 99 degrees Fahrenheit. A fever is when the temperature is elevated, higher than the normal range. The hypothalamus is your thermostat, so it sets your temperature. Damaged tissues, as well as products of pathogens, can function as pyrogenes. Pyrogenes are chemicals that are going to go to the hypothalamus and reset the temperature to a higher temperature. The chills that you feel are due to the fact that a normal temperature feels low, since the hypothalamus has set the temperature higher. So what are the effects of a fever? There are advantages to a fever, and studies have been performed where they looked at mortality rates and compared individuals who took a fever-reducing medication and individuals who did not, and they saw mortality rates were higher in individuals that did take the medication to reduce the fever. However, there are certain situations in which you do want to reduce the fever. So this is a case-by-case situation. So what are the effects of fever? It enhances the actions of interferons. Recall that interferons are going to be used against viruses. It also inhibits microbial growth. It's believed that it helps the liver sequester zinc and iron. So that means that it prevents the bacteria from having access to the zinc and iron, and bacteria need these minerals to grow. It also increases the metabolic rate of your tissue cells. This will help with the repair. And it will increase the activity of neutrophils. It increases the respiratory burst of neutrophils. Lastly, I wanted to cover the cells of the innate immune response. Granulocytes consist of neutrophils, which are phagocytic cells, eosinophils, which are also phagocytic cells, but primarily are involved in eliminating parasitic worms, and basophils, which release histamines to initiate inflammation. Macrophages. Remember, macrophages are monocytes that have left the blood vessel. They're phagocytic. NK cells are actually natural killer cells, and natural killer cells are going to be used against virus-infected cells as well as tumors. They're going to secrete two toxins, perforins and granzymes. The perforins poke holes in the plasma membrane of the infected cell, and the granzymes go through those holes into the cell and trigger the cell to commit cell suicide. Cell suicide is called apoptosis. This ends this module. I'm going to encourage you to study this information and learn it before you move on to the 4th module.